Start with exercise 12.3, question number 5. It says from each corner of a square of side 4 cm, a quadrant of a circle of radius 1 cm is cut. Also, a circle of diameter 2 cm is cut as shown in figure 12.23. Find the area of the remaining portion of the square. So, the diameter for this circle is given as 2 cm. That means the radius is 1 cm. And the corner circles are actually radius of 1 centimeter again. Now, so in this case, we need to find the area of the remaining portion of the square. So first of all, you need to calculate area of the square. Area of square ABCD. It is 4 into 4 as given in question. It says square of side 4 centimeter. That means 16 centimeters square. Now, the white part covered here at point A, B and C and D. These are actually the sectors. So you know that whenever we have an angle of 90 degree, it is known as quadrant. So we need to find area of one quadrant and we will multiply it with 4. So 4 into area of one quadrant. So theta is 90 in quadrant, 90 over 360 degree into pi r square. 22 over 7, R is 1. So the answer to this is 22. We can reduce it. So it will be 2, 11. 11 over 40 centimeter square. So this is area of one quadrant. We need to multiply it with 4. So 22 over 7. Area of 4 quadrants is 22 over 7. Now we need to find the area of circle which is in the middle. So that will be area of one circle, that is equal to pi r square. So 22 over 7, r is 1 square, 22 over 7. Now we need to take area of square ABCD, take away area of 4 quadrants and circle. So area of remaining portion is so area of square ABCD is 16 and area of 4 quadrant is 22 over 7 and area of circle is again 22 over 7. So 16 minus 44 over 7 will be 16 over 7. This, when you solve this, you will get your answer as 68 over 7 centimeters square. You need to take LCM of these two numbers, then you will get this answer 68 over 7 centimeters square. Let's start with question number 6. So it says, in a circular table covered of radius 32 cm, a design is formed leaving an equilateral triangle ABC in the middle as shown in figure 12.2. Find the area of the design. So in this case, we need to find area of the design. Now, for that, we need to have area of circular table cover and we need to take away area of equilateral triangle from it. Now, the problem is we don't know how to find in this case area of equilateral triangle because the side is not given to us. So, in this case, we need to take a centroid here. So, let us redraw this equilateral triangle here. So, let us suppose this is my centroid O. And whenever we draw a centroid, it means that we are dividing it into two equal parts, that is AO over OD equal to 2:1. That means OA value is given to us, that is 16, because radius is given to us. OD is not given to us. No, sorry, it is not 16, the radius is 32, so it will be 32 here. And OD will be 16 when we solve this part. So OD is 16 centimeter. Now 32 plus 16 will be our AD, that is 16 plus 32, so it will be 48 centimeter. Now we need to find that what will be the side AB in this case. So as you can see in triangle ABD, ABD is a right angle triangle, so we can use Pythagoras theorem to solve this equation. So as we know that we are taking equilateral triangle, so all the sides will be A, and as you know we have drawn a line AD, so it will be half of A, that is A by 2. So now I would be calculating my A. So in triangle ABD, I'm going to use Pythagoras theorem. So it will be hypotenuse square, that is AB square, perpendicular square, AD square, plus BD square. My AB is A square, my AD is 48 square, and my BD is A by 2 whole square. Now A square, take away A by 2 whole square, equal to 48 square. Now we need to take the LCM of it. So it will be A square minus A square over 4 equal to 48 whole square. So it will be 4A square minus A square over 4 equal to 48 square. And this will be 3A square over 4 equal to 48 square. Now when you solve this part, you will get your answer as 32 under root 3. That means your A is 32 under root 3. Now we can easily calculate area of triangle, equilateral triangle. So you know that the formula for area of equilateral triangle is under root 3 4A square. Under root 3 4A is 32 under root 3 whole square. So when you solve this part, you will get your answer as 768 under root 3 centimeter square. Then we need to find area of circular cover table. So area of circular table will be, as radius is 32 centimeter, so it will be pi r square. (22/7), r is 32. So the final answer for this is 22,528/7 centimeter square. Now you need to take away this value from area of equilateral triangle. So it will be 22,528/7 minus 768 under 3 centimeter square. Now let's move on to the next one, seventh question. In figure, ABCD is a square of side 14 cm with centers A, B, C and D. Four circles are drawn such that each circle touch externally two of the remaining three circles. Find the area of the shaded region. So in this case, we have again four quadrants. That is from A, the second one from B, third one from C, and then fourth one from D. So we have again 4 quadrant. First of all, let us find for one quadrant, area of one quadrant. Ninety over 360 into pi r square. Now the radius is 14 centimeter. Sorry, the side is 14 centimeter. That means radius will be 7 centimeter. So 7 square. 77 over 2 centimeter square. This is area of first quadrant. We need to find for 4. That means it will be 4 times 77 over 2. So 2 and 1, that is 77 twice is 154 centimeters square. Now we need to find area of square. That is quite simple. Area of square is 14 square. So 14 square is 196 centimeters square. Now we need to find the area of shaded region. So area of shaded region will be area of square, take away area of 4 quadrants. So area of shaded region, area of square, take away area of 4 quadrants. So area of square is 196, take away 154. So the answer will be 40.